Okay, so we just discussed alpha and beta decay. And alpha and beta decay occur naturally. So this is elements trying to become more stable. There's something also known as artificial transmutation that occurs. So these are man-made processes. So a stable atom can be bombarded with another nucleus to form a new isotope. So stable atom bombarded with another nucleus to form a new isotope. So there are times when radiopharmaceuticals need to be used. So these are radioactive drugs. And they're so unstable that if you ordered them from a company and you got them via UPS or FedEx, you got it overnighted, that even then they wouldn't exist because they've already decayed. So sometimes radiopharmacies exist in hospitals where these radioisotopes are generated very quickly. Now, this might be for imaging, this might be for cancer treatment, whatever it may be for. You couldn't buy this from a company that sells these radiopharmaceuticals. You have to make it on site. And so they use artificial transmutation. Sometimes you might hear about particle accelerators. These also use artificial transmutation. So they're trying to create new radioisotopes, trying to figure out if other elements exist. So it's pretty neat, actually, that they can do this. So here's an example of artificial transmutation. Boron-10 is bombarded with an alpha particle to produce nitrogen-13 and a neutron. So one of the things that this problem involves to produce, this is an arrow. So on one side you have your reactants, and on the other side you have your products. So with artificial transmutation, there's a product that you're interested in. Might be imaging radioactive isotope that you need to use. So in this sentence, boron-10 is bombarded with an alpha particle to produce nitrogen-13 and a neutron. There's enough information there to fill in this equation. So boron-10 is bombarded with an alpha particle to produce, that's the arrow, nitrogen-13 and a neutron. Now this is the first time we've seen a neutron in a nuclear chemistry equation. A neutron, remember, has 0 charge but a mass of 1. So that's the symbol for a neutron. Okay, so boron has an atomic number of 5, and nitrogen has an atomic number of 7. So just as before with alpha and beta decay, the sum of the mass numbers on the left should equal the sum of the mass numbers on the right. So 10 plus 4 should give you 14. 13 plus 1 gives you 14. 5 plus 2 gives you 7. 7 plus 0 gives you 7. So this checks out. So this is an example of artificial transmutation. So on the next page, I have some practice problems written out for you. I have these practice problems. Let's go through this one together. Argon-40 is reacted with a proton to produce a neutron and another radioisotope. What is the radioisotope formed? So a proton is 1 over 1 p, or 1 over 1 h. It has a mass of 1 and a charge of 1. A neutron has a mass of 1, a charge of 0. An electron, mass of 0, charge of -1. So these are very helpful in writing up artificial transmutation equations. So let's go back to this example. Argon 40 is reacted with a proton. So argon 40 reacted with a proton, 1/1, P, to produce, there's the arrow, a neutron. So that would be 1, 0, N. And I've had students who came up with this, and I thought this was really clever. A neutron spells ion. Get it? I-O-N. So sometimes I have students who switch around the 0 and the 1 with the neutron. And we are trying to figure out this missing radioisotope. So we need to look up the atomic number of argon, which is 18. And so we can do 40 plus 1 gives you 41. 18 plus 1 gives you 19 here. So I need to have the same sums on this side. So I'm going to have 40 here and 19 here. So atomic number 19 is potassium. So our new radioisotope is potassium 40. So I have some nuclear reactions that need to be balanced or written out. I want you to have your periodic table nearby and balance these. So hit pause, do that balancing, and then when we return, I will go over the answers for you. Okay, so for number 1, the answer that you get is iron 26. Number 2, you get that ion, or the neutron. Number 3, you get oxygen 17. Number 4, this is what your equation looks like. Beryllium, number 4, plus 4 over 2 helium, so that's 13. 12 plus 1 is 13. 4 plus 2 is 6. 6 plus 0 is 6. Okay, so it gives you a neutron plus carbon 12. Number 5, boron 10 is bombarded with a neutron to give lithium 7, and it's an alpha particle. Number 6, the missing particle is oxygen 16. Number 7, the missing particle is an alpha particle. And number 8, the missing product is an alpha particle. So that concludes artificial transmutation. I definitely encourage you to practice these. Again, these look a lot harder than they are, but they will be hard if you don't practice them. So be sure that you practice. Practice, practice, practice.